Hey Manny, nice ukulele. Did you find that here in the museum?
No, I actually brought this one myself, you know. Check this out, yeah?
Okay, you're a scientist and a musician. Nice.
No, it's not like that. I'm just trying to see a little vibe in it.
See a vibe?
Yeah, you see, every tune, it starts with vibration. The strings vibrate, pushing air back and forth.
Okay, I get it. You're talking about sound waves made by air getting squished and stretched 100 times a second?
Exactly. But I think we can take it up a few degrees though, if you get what I'm saying.
I say, let's go to Wonderlab and get lit.
Let's do it.
Let's go.
All right, cool. So right here, we've got a Rubens tube. Now inside the tube, we've got some gas flowing. And we've also got some little holes that's letting out the flames. Now, we're using this keyboard to play a sound into the tube. And the sound is going to get bounced around and reflected inside there, similar to how ripples overlap in a pond. Now, these are called pressure patterns, and it's called a standing wave.
So inside, the air pressure rises and falls. Now where the pressure's the highest, the antinodes, more gas escapes and the flames shoot up. Where the pressure's the lowest, the nodes, less gas escapes and therefore the flames dip.
The same thing happens inside instruments as well. Sound waves bounce around and reflect, and they create these same pressure patterns. That's how you get the sound from a flute, guitar, or even your own voice.
New note, new pattern.
The wavelengths changed. Shorter waves, more peaks. It's pure physics that we can actually see with our eyes. Now, standing waves shape everything, from music to medical scanners. So next time you feel that bass drop, that's physics you're feeling.